So as I said, we are here today for a power session, an AFSIA Showcase. You know, those are short sessions, 30 minutes, really to go straight to the points and focus on one very specific topic. And today we are joining Kevin Robinson from LONGi. LONGi Solar. Sorry about this, to speak about key considerations for high efficiency product performance for your PV system. So as you all know, there's a lot of developments, constant developments when it comes to solar modules. And Kevin is here today to tell us about some of those latest developments, which can make a difference when you're planning, building, financing your solar systems. And of course, ultimately increasing your performance and also increasing your ROI. So before I hand over the word to Kevin, just a very quick word of housekeeping. You know the drill, but just to be sure, the full presentation and the recording will be shared after the event, so no need to ask for this. Of course, you will get all resources. And then also in terms of interaction today, you really have like two main options. You have the chat option, you have the Q&A option. The chat is to say hi to everybody, to connect, to share some email addresses, to share some thoughts in general, to generate discussion in the chat. The Q&A is really directed to Kevin, because if we don't get time to address all your questions today, these will be recorded and Kevin will get a chance to follow up with you later after today's presentation. So please make sure that you use the Q&A section if you want Kevin to address your question. This is it for my part. So without further ado, I want to introduce our key speaker today, Kevin Robinson, Technical Support Specialist at LONGi Solar. He is based out of Cape Town in South Africa. And well, needless to say, Kevin comes with all the right expertise for today's session. 25 years experience in engineering and manufacturing, 15 years specifically in the solar industry. You see some of the big name companies that he's been working with previously: Jinko, Tenisol, Renewable Energy Consulting. And really, Kevin, correct me if I'm wrong, but you've specialized in solar module manufacturing since 2008. So I don't think there's many people out there who are more expert than you on today's topic. And I'm very happy to welcome you today. And please, the floor is yours, and we're very eager to hear about what you have to share with us today.
Oh, thank you very much for that that introduction, John. Yeah, so today I want to talk a little bit about this particular product, HARMA 4 series range, which is a 54 cell module. And, you know, I think one thing is always quite interesting, especially in the residential market, or at least the small and commercial type of installations, is always this confusion about what is the best module to choose, because so often everything is evaluated on cost per watt. And quite interestingly enough, I was watching a webinar by one of our peers, and he said one of their most popular ranges was a very large format module for residential market, because people think that this is most technologically advanced. Sorry about that. Which I found it quite interesting that he found it, and he mentioned that it was short-sighted. So yeah, I think modules are an interesting space, and hopefully to share today, I can impart a little bit of information about sort of the way we approach our business and some of the considerations that we think about when trying to offer a product to a customer, to try and ensure that they can try and maximize the value, considering that we we consider the entire lifetime of the module, not just the impact of the initial capital expenditure cost on the solar module. So really a focus on quality, reliability, and levelized cost of electricity, so ensuring the best value over the project lifetime. So with this particular product, LONGi has what we call the HiMo series, high efficiency mono PERC. We've always been a monocrystalline company. And the number five just refers to the series of solar cells. So as the industry has grown and developed, we've introduced new technology, new series, and the HiveMo 5 is now the fifth generation. So this particular model, it's built out of the M10 wafer size, which is 182 millimeter solar size. And the approach that, as I've mentioned, we use and when selecting the products that we offer to a customer is to try and like really optimize the levelized cost of electricity and consider the entire plant costs and production. So it's building on the M10 wafer, trying to see how we can optimize a balance of system costs for the entire power plant over its lifetime. You know, with this particular model, one of the big considerations for the residential market or small commercial industrial and even off-grid, I think is really around trying to optimize the module dimensions. So it has an impact not only on people being able to carry these modules when they're doing the installations, but it also has an impact on the reliability of the products. And I'll talk a little bit about that, that later. So size doesn't always bring the best value. In fact, as you go to the larger size modules, it can actually bring some risks with reliability, especially around the mechanical properties. So, you know, when we look at this module, considering the feasibility costs, reliability, the entire system, transport and logistics costs, as well as the installation costs as well. So a little bit more about the HiveMo 5. Last year, or actually, yes, last year at Intersolar, the HiveMo 5 was recognized as with getting an award at Intersolar. So this was quite something that we're quite proud of. So this particular product that got the award was the largest 72 cell format module using our gallium doping technology with the M10 or 182 millimeter solar cells. So really this smaller baby brother is essentially just building on the success that we have had with this particular product. So since the launch of the HiveMo 5, the larger big brother, the 72 cells module last year, in the first around about 8 months of supplying this product, we shipped over 10 gigawatts to a number of different countries. And you know, I think that in itself is quite a testimony to the kind of product and the value that we're offering the customer. Another industry award that's also important is getting the recognition from outside parties. So we got a very good award from PV Magazine Test. So with this independent testing, they look at a number of different factors, and you know, something that in the past with the mono PERC has been quite an issue is looking at things like light and elevated temperature-induced degradation losses, and also the light-induced degradation. So this is something where, you know, with the unique technology or the gallium doping that LONGi is using instead of the boron doping, it gives us the ability to offer a slightly better performance thanks to the reduction of the kind of degradation that you experience in the field. Another thing that we got highly scored on was the visual appearance, especially when you start to think about electroluminescence. So this is when we use cameras to actually see, looking for things like hidden micro cracks. And these are all things that impact the lifetime and the performance of the module. So great to see there that we get that little bit of industry recognition. So as I said, the HiveMo 5M or the 52 cell module is the little brother of the larger format 72 cell HiveMo 5 series that we have already gained quite a bit of success with and recognition from industry. So once again, built on the M10 182mm standard wafer size, using the gallium doped solar cells instead of boron doping, which gives us some advantages around reducing the kind of losses that you would have with a solar cell with boron doping. Module efficiency exceeds 21%. We use a 9 bus bar solar cell. So this is something that's already quite mature in the industry. Something that's, I guess, more interesting for guys doing installations, because of the size of the module. It's much easier handling, and of course able to withstand the mechanical loads. So if we look at this particular product, offering it in the two different sizes, or 2 different ranges rather. So we offer it in a standard module. So standard aluminium frame, white backsheet. The module size there is under 2 meters squared with a weight of 21.5 kilograms. So it gives it easy handling properties, especially when you sort of installers are working on their own, rather than the large format modules. You don't have some of the issues that comes around handling and loading. We're also able to offer this product in an all black range. So this is with black backsheet, black aluminium frames, anodized frames. So especially for those kind of projects where you want a something that looks homogeneous with the roof. This is quite an appealing product to use for those kind of things where aesthetics are quite important to the end user. So some of our product advantages, I've talked a little bit about the energy yield. So let's talk a little bit about that in more detail. So with the gallium doping, we're able to get slightly better performance at high temperatures. So what this means is that if you're considering the energy yield, especially during the middle parts of the day, where the temperatures are generally hotter and you have higher irradiance, you're going to get better energy yield out of the product. What we also get is this better low light irradiance performance. So in the early afternoon, early morning, late afternoon, when we have the lower irradiance, we're able to extract a better performance out of the module as well. IAM, that's incident angle modifier, and that's really just some glass properties. And by having better optical performance out of the glass, obviously able to improve the performance in that part. And finally, with the lower degradation, the gallium doping is different in that the industry standard up until now has been more focused on using boron doping. Gallium is still an element in the same category, so it's still got 3 valence electrons. But what it does offer is that it gives us much better degradation compared to boron. So once again, it's just focusing on giving value to the customer in that we're thinking about not only power of the module itself, but also considering that how much energy are you actually going to get out of this product during the lifetime of your project. Something that we do slightly differently that's unique to us. Historically, we used to use a flat type of ribbon, and then with the multi-bus bar solar cells, industry started using a circular ribbon. We do something slightly different in that we call this smart soldering or segmented ribbons. So if we look at the first portion of the ribbon over here, looking at the cross section there, we see it's this triangular type of structure. So the advantage that this gives us is that should any light that would normally get deflected out of the module, any light that hits this triangular structure will then get reflected into the solar module. So we're trying to optimize the amount of light optical losses by reflecting that light into the module and capturing more, or being able to give more energy as a result. The next benefit is that in the section closer, in the second red area or the circular area, the ribbon transfers to a flat section. So the benefit of this is that it allows us to move the cells closer together, but it also reduces the actual tensile strength on the solar cells. So with the lower stresses, it means that there is much, the potential for cracking around those stress areas is much lower. With the lower micro cracks or cracking solar cells, it means once again, over the lifetime of a project, what we're considering is that with the better durability, it gives this lower degradation, giving much greater energy performance over the lifetime of the module. With regards to the warranty, standard LONGi warranty with a 12-year manufacturing warranty and a 25-year power warranty as standard. With the warranty, we guarantee that you'll have more than 2% energy, or not more than 2% energy loss in the first year, and thereafter it's 0.5% per annum. If we're now looking at the mounting, how we mount this product, we're able to offer a variety of different mounting methods. So we're compatible with most of the type of mounting structures that we get in the industry. We can use the long side clamping in the defined clamping zones, clamping on the short sides, and then as well as corner clamping with the type of dome structures that that are also offered for flat rooftops. So we're able to we're able to offer that. Just one thing to consider when looking at the different type of mounting methods, just consider that the type of loadings that the modules are able to withstand are reduced according to the different type of clamping methods. So bear in mind with that. If you have any questions, ask us. All of this information is in the manuals, so it will define this in more detail. With the larger modules comes higher current, and this can particularly be a problem for, especially as we start moving with the larger format modules, when we are dealing with the inverters. You know, up until now, most of the inverters will have up to 26 amps threshold on the input of the inverters. So by staying under this this 15 amp threshold, it ensures that we don't exceed that input current of the inverters, but it also allows us to stay within the input parameters of the modules, especially when you're using two strings going into a maximum power point tracker. Talking a little bit about quality now, what we've seen is that, well, we know that IEC testing is not sufficient to predict the entire lifetime performance of the modules. It's shown to be pretty good at predicting the infant mortality failures, so the failures in the first 2 or 3 years. However, these voluntary testings with different laboratories, the PV Evolution Labs with their module reliability scorecard, and RETC with their higher achiever, these type of tests test beyond the IEC standard. So depending on where it is, between 2 and 3 times higher than the IEC standards. And in order to, just taking a step back with the IEC standards, with their testing, their benchmark is 5% degradation after the series of testing. With the high reliability testing with these two labs, in order to be a high achiever, you should have not less than 2% degradation. So considering that you have 2% degradation over a test that is 2 to 3 times higher or more stressful than the IC testing, it really gives comfort to people that we're considering the lifetime reliability and performance of these modules to ensure that a customer will maximize the energy yield over the lifetime of that product. And just borrowing some slides from PV Evolution Labs, this is some results of their testing, looking at 2 different modules. The first one here, full mechanical stress screening. Once again, beyond the IC testing, we don't know the module brands, but this was just to give you an example of 2 different modules. So in the first instance, this particular module, after the full stress screening, has degradation of 1.72%. However, with a different bill of module, with a different bill of materials, this particular module had 5.74% degradation after the same round of testing. So although the modules might look the same, if we consider that degradation and the impact it has on the entire lifetime of the project, it can be a huge or significant impact on the energy yield. Once again, looking at this damp heat testing, once again, the 2 different bill of materials. Once again, the manufacturer manufacturers weren't disclosed, but just looking at 2 different bill of materials. After this series of testing, you can see the kind of degradation between the 2 modules. So this is the kind of value that we can offer to a customer as top performer, showing the customer that we can offer them a better lifetime performance out of these particular products. And then just in summary, when we look at the life cycle and quality system, really considering a number of different things, from the design, the materials, the reliability testing, quality management systems in the manufacturing process. And then finally, one of the biggest considerations is the outdoor power generation. So making sure that the customer is getting great value from energy performance. All right, great. Thanks very much. These are my contact details if you reach out and ask any questions. John, back to you.
Yes, Kevin. Disappeared for a second. Thank you very much for this presentation and overview of the latest development on your side in terms of technology. I'll jump right into it with some questions. We have I'll start with the easy one. Priska, what is the price of your model?
Honestly, it's I'm going to use a little bit of a scapegoat here. In that I'm working in the technical team, not the commercial team. But please, yeah, contact me on those contact details. Can put you in touch with the commercial guys, and they'll be able to give you assistance on your particular requirements. Yeah, just something to comment on that part is that I think something that's been quite difficult over the past 2 years is with the pandemic and shortages and logistics problems. It's been incredibly volatile. So pricing is pretty difficult to say in a generic term, because it's depending on a lot of different factors. So yeah, reach out to me and I'll put you in touch with the commercial guys who'll be able to chat about that specifically.
A little bit unrelated to this discussion, but still an important question, and all questions are welcome, from Veronica. Bifacial panels, what would you say are their advantages, and do you see some specific applications in Africa?
Yes, certainly. So bifacial is an interesting topic, and it's I would say for the most of the type of installations that we are involved in, the commercial, industrial, residential, and even some of the off-grid projects, it probably does not make sense. Obviously, it's very project specific. Bifacial, obviously, the advantages of the technology is that you're generating power from both sides of the modules. However, there are a lot of design parameters that really do impact how much energy you get out of the module. So how high the modules are installed over the ground, the type of material that you have, the reflection we get from the environment, the albedo, what are the soil conditions. So there's a whole lot of varying parameters, and it's very project specific. So it's not easy to say yes or no. I think it's quite a specialized project specific topic. But certainly, yes, it is interesting from the point that you do get energy yield. However, very, very project specific. But yeah, happy to chat to you in detail about your specific requirements, and we can see how we can help you.
Still staying in the African context, so we understood from your presentation that there are many different parameters to look at. But would you say there are some parameters, some aspects of solar modules which are more important to look at when you are developing a solar project in Africa? For example, because of temperature, for example, because of specific regions or something like this. What should people pay more attention to?
This is always a difficult discussion, because people in Africa are desperate for power, and quite often the constraints are around pricing. So the easiest or most natural choice is to go for the cheapest products, because that's the easiest way to get power in a fast way. My advice is really to understand that quality and reliability really do impact the entire lifetime of the project. So by maybe paying a little bit more, you get a product that is more reliable, more durable, and the actual value that the customer gets out of that is increase in energy yield and reliability over the lifetime of the product. So even though we would offer maybe a 25-year warranty, the expectation is that you would get maybe 30 or even 35 years out of the product. So I would say quality and reliability is hugely important, but obviously with the understanding that Africa is a very price-sensitive market.
Specifically bouncing on this aspect of lifetime performance. So yes, of course, there are some commitments from you and other manufacturers in terms of specific percentages that are still being achieved in the next 10, 20, 25 years. But realistically, for a company which does an installation on their rooftop or an individual installation on their house, how can they actually verify this? How can they be sure? How can they be sure that this is not because of lower production, it's not related to specific water conditions or something like this?
You are breaking up a little bit, so I'm not sure if I understand the question fully. I missed the end part. I think that making sure that you getting a quality and reliable product. The first benchmark has always been the Bloomberg, the tier 1 criteria. So people say as long as a module is tier 1, then we're happy with the product. This is not always the best metric, because if we look at the Bloomberg criteria, they actually say that it doesn't guarantee the quality or reliability of the products, but their criteria is to have financed 6 1.5 megawatt projects with non-recourse finance over a 2-year period of time. Non-recourse finance just means that the money that pays back the loan from financing the project is only generated from the revenue from selling the energy from their product. So it doesn't mean there's no other way. So there's no securities involved. So 10 years ago, that was quite a big deal. These days, solar is widely adopted, so it's not really a great way to consider or a choice or a metric for choosing solar modules. IC is also important for the customers to make sure that the products are IC certified. And normally they should have some labels on the data sheet or brochures or whatever indicating the type of certification that the products do have. What I would recommend is, for sure, an individual can't verify specifically, but do a little bit of research into the company, have a look at how financially stable is the company. And the reason why financial stability is important is that if anything ever does happen, you need to have some recourse in being able to go back to that company and saying, our product is not working, please replace it for whatever reason. And then another important consideration is have a look at the type of voluntary testing that the company participates in. And some of these can be the ROTC testing that I mentioned. PV Evolution Labs out of the US, they do a module reliability scorecard every single year. Every single year they do these testings. It's voluntary testing, so the manufacturers let the company know that they'd like to participate in this particular year's testing. The labs will come and actually visit the factories. They do an audit in the factory. The products then get shipped directly to their laboratories, and they do the testing in their labs. So, and then the data is shared publicly. Okay, although the names aren't specifically mentioned in each of the tests, there is a list which shows the top performers in each of the categories. So it gives comfort. There are also different companies that do outdoor testing. PV Tech, they do outdoor testing, and they will show the type of energy yields that they're getting from the module manufacturers. So I would say maybe just have a look and see at the type of things that the company is involved in, looking at energy yield, quality, reliability, as well as financial stability of the company.
Fair enough. Several aspects to look into, but relatively accessible information. So everybody.
Most of the information is publicly available. Yes.
Everybody needs to do their homework so that they can make a informed choice. I'm looking at the time. We're slightly over time, but I would like to ask a few more minutes just for respecting the commitments of everybody's schedule. Question about TopCon. How? So there's been several articles about this term. For people who don't necessarily know all the ins and outs of solar module technologies, how does this compare to what you have? How does this differ? How should people look at that?
Okay, so TopCon is quite a topical discussion at the moment. The industry has been going back about 5 years. It was heavily polycrystalline dominated, and then the industry has shifted over to monocrystalline PERC technology, and there have been a number of changes with the wafer size increasing. So we've got to this point where the wafer sizes and the cell technology is pretty mature. So the next level is looking at different high efficiency technologies. So N-type solar cells have got some advantages in terms of the degradation. And so this is where the industry is starting to look and where it's moving into the N-type technology. TOPCon is one of those technologies. There's also heterojunction, and we're also looking at IBC, or integrated back contact cells. So yes, industry is moving that way. Our view is that with N-type technology, there is additional cost associated with it. And I think before it becomes mainstream is probably going to be maybe another 2 to 3 years. But obviously, it's a dynamic situation. Things do change rapidly. But right now, our view is before it becomes real mainstream, it's probably going to take another 2 to 3 years to completely replace PERC technology.
You're switching to a completely different topic. From what you said, size does matter, but bigger doesn't always mean better. From a pure, if you put yourself in the shoes of an end user, so really like the person who will benefit from the solar system, who ultimately makes a decision to work with a specific EPC company, would you say they should have a say in the size of the panel? Should they be concerned? Should they be giving directions to their installation partner? Or do you have any other advice from that side of the installation?
John, honestly, taking a step backwards, if you're installing solar, go ahead and do it, and do whatever you can practically achieve. I think these kind of size discussions probably become more topical with the larger EPCs and sort of moving towards the utility scale power plants, where maybe the technical advisors and financiers have more say into the products that they're selecting. These kind of projects, they spend a lot of time on technical advisors actually studying in great detail some of these aspects. So for residential, small commercial, off-grid, install whatever you can. But I think the consideration is that, what suits you best. The smaller modules have advantages in that they are easier to handle. They do have better mechanical durability properties, which can impact the degradation and lifetime performance of the modules. So I have in my mind that a HIMO 5 series really covers those different things very well. But I think as an individual user, it's quite hard to specify those kind of products per se.
Fair enough, makes total sense. And actually, we have end users listening to us today. We also have quite a lot of people, obviously, in the EPC business. Last question maybe for you today. How about distribution across Africa? I saw a question looking for information about where people can get their hands on panels. How do you normally work? Do you have distribution partners in each country? Should people always reach out to you or where they are based? How does it work for you?
Certainly, they can reach out to me. Our main business model is to have distributors in country. So we're busy building up that distribution network. I saw that one question was specific about Nigeria. So if you have specific requirements in a country, you can either reach out to me and I'll put you in touch with the commercial teams, and we can either help you directly or refer you to one of the distribution partners. So we do try and work with distribution partners in country. But of course, when it starts to come to bigger projects, where an EPC company would have the financial means to be able to import container loads on their own, yes, we're willing to engage with those kind of EPC partners as well.
Very good. Well, thank you so much, Kevin, for sharing a little bit of extra knowledge with us today, and for addressing the different questions that we received. Before I let everybody go, I'd really like to very quickly tell you about some upcoming events from AFSIA. If you liked today, maybe you like our next event even more. We're organizing our big annual conference, virtual conference on storage technologies next week, from Tuesday until Thursday included. We've got an amazing lineup of speakers, and we are going to cover all the latest updates, projects, technology for large-scale CNI and residential applications. So really all you need to know, all you ever wanted to know about solar storage, this is going to be discussed next week. And then, of course, we have the AFSIA Awards, which will take place, which will be co-located and organized in collaboration with the Africa Energy Forum. It's taking place back live, 100% live at the end of June on the 23rd. And the applications are closing on May 13th. So if you haven't applied yet, don't forget to do so. And of course, we hope to see you in Brussels in June. So this is it for today. Kevin, thank you again for being with us today and for educating us a little bit more about solar technology. I'll leave on the session on for a few more minutes in case you have a last minute question. And for the other ones, I wish you an excellent rest of the day. Thank you so much for joining us, and see you soon. Bye.